This is how we extract the most dangerous metal. Workers wear hazmat masks using toxic chlorine gas in a multi-stage electrolytic refining process. The high current magnetic field is strong enough to rip cameras and keys from your hands. Yet this terrifying environment is an inseparable byproduct of potash and chlorine gas production. This factory produces magnesium, chlorine and potash. The Solikamsk plant yields 75% of Russia's total output. Carnallite and seawater are essential raw materials for production. When the oceans dried up billions of years ago, they left behind solid potash beds. People mined these deposits, refining and purifying them into the snow-white carnallite powder you see here. After the founding of New China, the older generation ventured into the sea of death in search of this pungent carnallite and salty brine potash. The carnallite in the enrichment area is rich in both free and crystalline water, so it is fed onto a conveyor belt for physical dehydration. This cylindrical steel drum uses motors on both sides to keep the material inside tumbling continuously. Due to its size, the temperature inside the rotary kiln is not uniform. For instance, the temperature at the inlet end is only 140 degrees, while near the exit it reaches as high as 600 degrees. This requires workers to periodically pry the cylinder walls with steel rods to prevent the high heat from sintering the material. Additionally, the factory employs fluidized bed dehydration. This rusty fluidized bed has been running continuously since it was commissioned in 2010. It still operates at a capacity of 50 tons per day. The rotary kiln can reduce the moisture content of the carnallite to 7%. It is important to note that if hydrolysis and dehydration occur simultaneously, toxic chlorides will be produced. Next, the raw material is fed into the chlorinator for secondary dehydration. This step merely converts it into a higher purity anhydrous carnallite melt. When the temperature reaches 700 degrees, carnallite reacts in a molten state. By injecting chlorine gas, it binds with harmful chlorides, achieving a purity of over 99%. Once dehydration is complete, the next step is electrolysis to reduce magnesium ions into metallic magnesium. To achieve this, the factory has turned the entire room into an electrolytic cell. The first thing you see is graphite, and next to it are massive steel electrodes. During the electrolysis process, the cathode is used to reduce the metal into liquid magnesium, while the anode produces chlorine gas. Once the current is activated, tens of thousands of amperes surge into the busbar, generating a powerful magnetic field that severely interferes with all sorts of electronic equipment. And this all happens during the electrolysis process. Watch closely. When he places the key in his palm, the one held out in front instantly snaps straight up. The concentration of magnesium chloride is strictly controlled between 6% and 17%. 6% is the lower limit because once the concentration drops below that, the current starts attacking other ions such as sodium. Once sodium ions are attacked by the current, the magnesium becomes contaminated, which reduces its purity. It must not exceed 17%. If the concentration is too high, the quality of the carnallite melt deteriorates, making it difficult to separate the liquid magnesium, which directly reduces output. This concentration looks just right. Afterward, a device called a liquid pump is used to extract the melt from the electrolytic cell. The strong, pungent odor forces people to wear masks. Even in summer, they wouldn't dare expose any part of their body below the head to the melt. Furthermore, what is being extracted here is waste electrolyte, as the carnallite has already been electrolyzed. 72% of this waste electrolyte is potassium chloride, with small amounts of sodium chloride and magnesium salts. Once the potassium chloride solidifies into chunks, it can be broken up and used as fertilizer. It was this potash fertilizer that boosted crop yields in early China. China is the world's top potash producer and also ranks first in magnesium production. The strong acid from high-temp molten salt makes electrodes thin and brittle, reducing activity and dropping the current. Thus, graphite electrodes need periodic replacement. They are the insulators preventing electrical leaks. But electrolysis produces more than just fertilizer. It also yields a valuable byproduct, chlorine gas. The chlorine gas generated at the anode is dried using concentrated sulfuric acid before being sent to the evaporator. Since wet chlorine is highly corrosive, each of these tanks holds 12 tons of liquid chlorine. A leak of that magnitude would be enough to wipe out an entire town. Of course, this chlorine gas is also sold to chemical plants, where it is used to produce titanium tetrachloride. Titanium alloys are excellent materials. For instance, hospitals often use titanium for skeletal implants. Once the potash and chlorine gas have been separated from the magnesium metal, the process of refining magnesium ingots begins. First, reheat the magnesium to 720 degrees, then have a worker sprinkle in a small amount of sulfur powder. The sulfur acts as a covering agent here. It reacts with oxygen first, protecting the magnesium from oxidation because magnesium will burn in the air. Look closely at the scene where he pours out the liquid magnesium. Isn't there always a layer of pale purple flame? Sulfur dioxide itself is non-flammable, but it can act as an oxidizing agent, replacing magnesium in the combustion process. The pale purple glow emitted from the surface is like starlight lingering in the night. As for the casting molds, each one must be soaked in boric acid before it can be used to hold molten magnesium, as water reacts explosively with high-temperature magnesium. So, look at those people in front. They're dressed like bomb disposal experts. The freshly cast magnesium ingots are still at 300 degrees Celsius, and the workers have to stamp them as quickly as possible while they're still hot. It looks quite large, doesn't it? But let me tell you, this thing only weighs a quarter of the same volume of steel. Magnesium is even lighter than aluminum. Magnesium reacts violently with oxygen at high temperatures, so it is transported on pallets and wrapped in plastic rainproof tops.